a glimpse of the future. Your car silently gliding through city streets, no engine growl, no friction from gears, and no oily mess under the hood. You pull into a parking spot, and without plugging anything in, the car begins to recharge. All this is powered by a radical leap in engineering, the contactless motor. More than a clever tweak, it's a complete redesign of what it means to spin a rotor. These motors promise to change everything, from how we build electric cars to the cost of running city metros to the emissions profile of global shipping. It may sound like science fiction, but the groundwork is already laid. Prototypes are being tested, patents are piling up, and major research institutions are pushing the tech into reality. Let's unpack why this innovation is more than just buzz and why it could power the future of transport, clean energy, and beyond. Before we proceed to the video, don't forget to hit the like button and ring the notification bell so you never miss our upcoming videos. Why contactless matters: efficiency and loss. Reduction. At the core of the motor revolution is energy efficiency. Traditional motors lose 10 to 15% of their input energy to heat and friction. Brushes, bearings, and stator rotor drag all contribute to inefficiencies. Over time, these losses cost billions in fuel and electricity and increase emissions. Contactless motors, by eliminating direct contact surfaces, sidestep this loss. Friction is virtually zero, and clever use of air core or superconducting windings ensures minimal eddy current and hysteresis losses. The result? Up to 98% conversion efficiency, a dream figure for energy engineers. For electric vehicles, that means extended range without enlarging the battery pack. Maintenance-free operation. One of the most burdensome aspects of machinery is maintenance. Bearings wear out, gears grind down, brushes spark and erode. And in critical systems, planes, wind turbines, metro trains, scheduled servicing is non-negotiable. Contactless motors disrupt this entire paradigm. No friction means no wear. With no moving mechanical interfaces to degrade, these motors could run for decades with minimal upkeep. The economic upside is enormous. Reduced downtime, lower spare parts demand, and less labor-intensive repair protocols. Environmental upside. The environmental implications extend far beyond the vehicle tailpipe. Most motor systems require periodic oiling, cooling fluids, and consumable parts, all of which contribute to waste streams. Contactless motors use no oil, require fewer replacement parts, are quieter, reducing noise pollution, operate at higher efficiencies. How it actually works. The science behind the wonder. To understand how a motor spins without contact, let's dive deeper into the technologies behind it. Magnetic bearings and levitation. At the heart of contactless motion are magnetic bearings, which suspend the rotor without touching the stator. Instead of a physical axle, magnetic forces keep the spinning core in perfect alignment. Using either permanent magnets or actively controlled electromagnets, the rotor literally floats in place, like a miniaturized maglev train. This isn't just a gimmick. The benefits are tangible. No friction, no energy loss due to rubbing, no physical contact, longer lifespan, less vibration, quieter, smoother motion. Air core flags and induction fields. Most motors rely on iron core stators, which can be heavy and produce drag due to eddy currents and magnetic saturation. Air core contactless motors skip the iron entirely. Instead, they use light composite structures wound with copper or superconducting wires. This has several advantages. Lower inertia for quicker response. No iron losses. Higher speeds with minimal drag. Paired with vacuum insulation or cryogenic cooling, these air core designs can outperform traditional systems, especially where speed and precision are critical. Power flow, without wires. Perhaps the most sci-fi component is wireless power transfer inside the motor housing. Just like your phone can charge on a pad, these motors can transmit electricity from a fixed stator to a floating rotor using evanescent field coupling. Active control systems. All of this would fall apart without precise electronic control. Contactless motors rely on real-time feedback from optical, magnetic, and inductive sensors. These feed data into control processors that dynamically adjust currents, torque, and field alignment. The system works like a tightrope walker, constantly adjusting to stay balanced. Fail-safes and redundancy layers ensure stability under load, during startup, and even in rough environments. These feedback systems are where the true complexity and genius of contactless design lie. Without them, levitation fails, and the rotor crashes into the stator. Real-world applications and prospects. Electric vehicles, EVs. EV makers are under constant pressure to deliver more range, faster acceleration, and lower costs. Contactless motors offer a way to increase drivetrain efficiency, eliminate gearboxes and lubrication systems, reduce system weight, extend motor lifespan beyond 500,000 kilometers. Luxury EV brands could be the first to adopt contactless motors, offering whisper-quiet rides with unmatched smoothness. Later, economy vehicles could follow, leveraging long-term savings in repair and maintenance. Maglev and urban transit. Urban mobility is being reimagined, and contactless propulsion aligns perfectly with that future. Maglev trains already float, but their motors still involve some mechanical drag and maintenance-heavy parts. Upgrading to contactless systems could lower noise levels inside trains, increase energy efficiency, reduce wear on tracks, simplify maintenance in congested city settings. Cities like Tokyo, Dubai, and Shanghai are exploring next-gen transit systems that might rely entirely on contactless, autonomous, all-electric mobility. Drone and aviation applications. The drone revolution hinges on lightweight, high-efficiency propulsion. Contactless micromotors could extend flight times, improve payload handling, and resist dust, heat, and humidity. For electric vertical takeoff and landing aircraft and flying taxis, this could be the breakthrough that enables truly scalable urban air mobility. Heavy industry and marine propulsion. Marine shipping is one of the dirtiest sectors on the planet. Contactless motors could change that by offering higher torque, lower energy draw, minimal servicing, vital in open ocean, longer mission life for submarines and cargo ships. In factories, contactless systems could cut downtime by eliminating lubrication and regular bearing swaps, while reducing fire risk in volatile environments like chemical plants. The road ahead. The stars may finally be aligning. Costs for rare earth magnets, control chips, and automated machining are falling. Artificial intelligence and predictive maintenance tools are also smoothing the adoption path. Here's a likely timeline: 2025 to 2027. Pilot programs in premium electric cars, military drones, and maglev shuttles. 2028 to 2030. Entry into mass-market EVs and commercial vehicles. Standardization efforts begin. 2030 to 2035. Rollout in container ships, industrial robotics, and aviation support systems. Post-2035. Contactless motors become mainstream, particularly in smart cities and green manufacturing zones. From frictionless highways to self-repairing ships, the age of the contactless motor is dawning. This innovation holds the power to reshape our energy future, quietly, efficiently, and with elegance. We stand at the threshold of a transportation revolution, one where motion flows not through metal and grease, but through invisible forces, reliable, clean, and enduring. So the next time your drone lifts off, your tram pulls up, or your EV rolls to a stop, listen closely. You might just be hearing the whisper of the future. If you enjoyed what you saw, don't forget to hit the like button and ring the notification bell so you never miss our upcoming videos. Your support means a lot to us. Take care until the next one, and feel free to drop a comment sharing your thoughts. See you soon.